Right, so let's start with the statistics. We'll get to know what is the statistics, what are the types of statistics. So basically, we would get the idea of what is the statistics. Basically, what is statistics? So it is a branch of mathematics that deals with collecting data and interpreting data, organization and interpretation of data, right? Like it is a branch of mathematics where we just collect the data, interpret it, process it, analyze that data, and try to figure out some sort of information or try to make some decisions based on that data, right? So this is the whole idea of statistics. And that's why statistics is basically used for the data science or for the data analysis. Why? Because the reason is that the whole purpose of the data science or the data analyst is to just analyze the data and to make the decisions based on that data. So how are you going to make the decisions based on data? First, you have to apply some sort of the calculations. You have to do some sort of calculations. You have to gather that data, do the calculations on that data, and then you will come to some sort of conclusion, right? So statistics helps you to do that, right? That's why it is essential for a data scientist to learn statistics at the first place. So for statistics, we understood what is actually statistics. Then there are the two types of statistics, right? So we have descriptive statistics and we have inferential statistics. So these are the two types of statistics. We'll get to know one by one about each type of statistics. But for now, we are just starting off with the descriptive statistics. Now, what is the descriptive statistics? So it involves summarizing and organizing the data so they can easily be understood, right? So it is all about, we have the data, we have to just summarize that data and organize that data, right? So if we have some sort of like other data about the population or data about the employee that are working in a company. So first of all, before anything we do, we have to organize that data. We have to do some calculations on that data, like how many number of employees are there, what is the mean of that thing, of the number. This is all about the descriptive statistics. And descriptive statistics is broken down into the two categories. The first one is the measure of central tendency, and the second one is the measure of spread or the measure of dispersion, right? So these are the two categories of the descriptive statistics. We'll get to know one by one. First of all, we start off the measure of central tendency. Now, what is the measure of central tendency? That's a whole idea. Basically, if you just know that the central tendency is basically the idea that there is one number that can best summarizes the whole data. If you have a whole data, right? Let's say if you have a data about the age, let's say, I would say that I have the data about the age of employees, right? If I have the data of the age of employees, let's say we have the normal age like 30 or 29, we have 25, we have 28 maybe. So these are the data. Now, how do I get to know that in a way, which age group people are there in my company, right? So there would be a single number that best describes this whole data. There would be this one number that can easily describe this whole data. And you can say that this is the average age of employee that is working in my company, central tendency, right? It's because it is best summarizes the entire data set of the measurements. It is a number that is some way central to the set, right? Now there are the three types of the central tendency. This is the most asked interview question, that what are the types of central tendency, right? So you can say there are the three types of central tendency. That is the mean, median, and mode. We'll see it. Now let's start to understand what actually mean is, mean or an average, right? So if we talk about that, the average of the observation of the given statistical data, like if we have the data about some of the age, let's say the age of employee working in the company. So let's say we have like 34, 29, sorry, this is 2, 26, maybe 35. So these are the main ages of the employee working in my company. Now, that's, if someone asks me that what is the average age of the employee that is working in your company, how do I gotta say that? That's where the mean comes in the game. The mean says that don't worry, what you have to do, you just have to add all these numbers, all of the data. You have to just add all of the data and divide it to the number of the data that is given to you, which means that the sum of the terms divided by the number of terms. If I have this 1, 2, 3, 4, so these are the 4 number of terms. So in the denominator, I will write the 4. And in the numerator, what I'm going to do, I'll add this, the 34 plus 29 plus 26 plus 35. So whichever would be the result, I will just put it in the numerator and then divide it. And after division, the number will be the average age of the employee that is working in my company, right? So there is an example that if you have the numbers like 14, 12, 3, 8, 7, 9, 7, 11, and 16. So these are the numbers. What do you have to do? First, you have to add all of these numbers. You have to add all of these numbers, and you have to divide these numbers by the total number of terms, like 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the total number 9 values here. So you have to divide it by 9, and this would be the mean. So this is the average value of this whole data. This is the whole data, and this is the average value that describes this data, right? So this is the whole concept of mean. I hope you understand it. And it is for the ungrouped data. This is the ungrouped data. There is a little bit different for the group data. We'll see in the future. But for the time being, for right now, we are just focusing on the average mean for the ungrouped data. And this is this explanation. I hope you understand this. So let's understand what is median, right? So median for the ungrouped data. So median is a value that divides the data into two equal parts. The simplest definition that I could explain to you. If you have a data, let's say if you have ungrouped data, and if you wanted to divide the data into equal parts, there would be the one value that will be dividing that data into the equal parts. Then that value is known as median, right? So most of the people will say like it is the most middle value of the data. That's totally correct. We can also say that it is the most middle value in your data, right? So median divides the data into two equal parts. That's the number of terms on the right side is equals to the number of terms on the left side of the data when the data is arranged in either ascending or descending order. This is the condition for finding median, that your ungrouped data must be in either ascending order or descending order, right? Let's take an example. Like if we have a number like 14, 12, 3, 8, 7, 9, 11, 16. Now, this is the unordered data, ungrouped data, and it is not in any order, neither in the ascending nor in the descending. So first, what did I do? Is that data into the ascending order. And after arranging the data in the ascending order, I try to find out what is the median of that data. Now, there are also two conditions. Number one, that median will be the middle term if the number of terms is odd. Likewise, here is the example. If you can see that there is the total 1, 2, 3, 4, 5, 6, 7, 8, 9. There are the total 9 terms in this data, right? So 9 is an odd number, right? So the total number of terms are 9, odd number. So we can easily find out the middle value or the median of that data, because the middle value is the median of the data. So first I arrange it in the ascending order. You can also arrange it in the descending order. So I arrange it in ascending order, and then you can see that this number 9 is dividing the whole data. You can see that if I just create this, these are the 4 numbers, and these are the 4 numbers. And 9 is the only number that is dividing this two data set into the equal part. Like there are the 4 number here and the 4 number here. So 9 is the only one that is dividing the data into two equal parts. So it is known as the median of the data. But what if the number of terms are even? So if the number of terms are even, then there would be the 2 medians. In that case, you have to select the 2 things. Let's say if for an example, if I say that there would be another number, let's say 20 in this data, for suppose. So there will be there will be the even number of terms here. There will be the 10 terms, right? Okay. Now what do you have to do? For the 10 number of terms, you must have the 5 on the other side, 5 on the right side. So it is difficult to do that. So what you have to do in that case is to select the middle values. There will be the 2 medians in that case. How? Is that if you see, if I take this 11 also, now if I take the 9 and 11 as the middle value, so you can see that these are the 4 values here, these are the 4 values here. And this, you can say the 5th and the 6th term are the medians, but that is not the median. What you have to do is to just add these two, 9 plus 11, and divide it by 2. So 9 plus 11 will be divided by 2, and you can say that this would be the 20 divided by 2. That would be a 10. So 10 would be the value that is the median in this case, right? So this is how you can calculate the median for the even number of terms. For odd, it is like quite straightforward. You don't have to do anything in that case. I hope you understand this. Let's understand what is mod. Now the mod, we can say that it is the most repeated observation, or the term that has the highest frequency in your data, right? So if there is a term that is the most repeating or that is frequently appearing in that data, then you can declare it as the mod. For example, if I take the example of this, and 14, 12, 3, 8, 7, 9, 7, 11, and 16. So in this whole data, you can clearly say that 7 is the number that is repeating 2 times, right? So, and the rest of the numbers are repeating only once. So 7 is your mod because it's repeating most of the times, right? But there is a question that may arise in your mind, that there would be a data set where we can have no mode at all values would be unique. This would happen. Or you can say that we can have a data set in which where we have two numbers that are repeating at the same number of time. That likewise, in this case, if I just draw this, if I just increase this number of terms, like there is a 7, if I just say that there's another number here that is 9. So now 7 and 9, these both are repeating 2 times equally, right? So this case, we can say that it is the bimodal. There are 2 modes, right? It is called the bimodal. I have written here, it is the bimodal. Now, if 3 values are appearing at the same time or the more than rest of the value, it is called the trimodal, right? And if there are more values like 5, 6, 7, 8 numbers that are repeating at the same time, then it is called the multimodal, right? So there would be many modes in that case. So this is all about the mod in case of the ungrouped data. I hope you understand the concept. Now, let's understand what is the measure of spread or the measurement of the dispersion. It is the another category of the descriptive statistics. First one is the central tendency. I have already made a video on that. And now it is the measure of spread or the measurement of dispersion. Now what actually it is? So to evaluate the variations among the given observations from the given statistical data, we use measure of dispersion. Now, I know you don't understand this. Let me explain. So if there are some sort of the variations or changing that is appearing in the given observation from the statistical data, like statistical data, there are some values and you extracted some observations from that values, and there is some change between the actual values and the value that you have extracted, then we say it is the measurement of dispersion. We use measurement of dispersion for calculating that, because it always provides the true values. It provides the true values. So here, first of all, starting off with the mean deviation, right? So what is the mean deviation? It is an average of absolute differences between each value in a set of values and the average of all values of that set. Now, what does that mean? It means that if you have a whole set of data, the ungrouped data, and you calculate its mean. Now, what you have to do, you have to calculate the difference of each number of each data with the mean that you have calculated. So it will figure out what are the actual value, what is the deviated value, what are the variations in that value, right? Let me give you an example, but before that, you should remember this formula here that xi is minus x bar and it is divided by the n. What is this? Xi is the individual values that are present in your data. X bar is the mean that you have calculated from the data, and you have to sum all of these values, and then you have to divide it by the total number of terms that are present in your data, right? So this is the simple explanation of this formula. Let's understand it with the example. Now I have this example. It is just handwritten. I just took the screenshot of this. So let's say if we have a data 567, 575, zoom this, 567, 575, 573, 568, 571, 572, 578, 571, and 565. Now, these are the ungrouped data that you have. Now, how do you calculate the mean deviation in that data? So the first, you have to calculate how many number of terms are there. You can see 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are the 9 numbers. So total number of terms are 9. Now, then you have to calculate the mean. How do you calculate the mean? It is like similar to the normal way that we calculate the mean. We took the sum of all the numbers that are present in the data and divided by the total number of terms. So we get the sum of all of these and divide them by 9. We got this mean here. So this is the mean. Now we have to check how this mean is deviated or variated from the actual numbers that are present in your data. For this, we have to calculate this. So we have these are the actual values, and we have to subtract it with the mean that we have calculated here. So 567 minus 570.56, this is the value you got. For this value, you subtracted by the mean value and you just got this. And similarly, you just subtract each and every value with the mean you have calculated and you got the number. So these are the numbers, are the actually, you can say, the deviated values, right? So again, now you can see that in the end, what we did is we calculate the sum of all of these numbers. You just calculate the sum of all of these numbers and divide it by the total number of terms. So we got this value, that is the mean deviation. This is the actual mean deviation that is present in our data after calculating the mean. This is how you calculate the mean deviation of the data that is present. So I hope you understand this. Now let's understand what is the standard deviation, right? So standard deviation is a measurement of the average distance between each quantity and the mean. That is how data is spread out from the mean, like how much there is a difference between the data and the mean. A low standard deviation indicates that the data points tend to be close to the mean of the data set, while a high standard deviation indicates that the data points are spread out over a wider range of values. Like if we calculated the mean of the data and then we calculate the standard deviation, if the standard deviation has a low value, then we can say that the mean that we have calculated and the actual values, they have a little bit of difference, not that much. But if the standard deviation is high, then we can say it indicates and we can say that the data points are spread over the wider range of values. Like there is a huge difference between the actual data and the mean, right? So this is, or you can say that the data points are spreading on a large or on a large scale. Like, but if the data points are if the standard deviation is low, then we can say that, okay, so the data points are in a low scale. Now, there are like two variations of the standard deviation that when we are asked to find the standard deviation of the some part of the population, like for the some part of the population, not the total part of the population, then we use the sample standard deviation. Now, in this, that we have this x, that is the individual value. This is the x bar, that is the mean of the value, mean of the whole the segment of the population. And we just square it. Take the square and divide it by the total number of terms minus 1. The total number of terms minus 1. And in the end, we took the square root of this thing. Right? So this is the basic formula for the standard deviation if we have to calculate the standard deviation for the specific part of the data. But if they say that you have to take the whole part of data or the whole population, then there's a standard deviation formula that is like you have to calculate this mean. Yeah, you have to take this like the individual points, you have to square it and divide it by the total number of data. That is the main difference between these two. This is the n-1 and this is the n. This is just the main difference between these two formulas, that if you have to take the standard deviation of the specific part of the population of the data set, then you have to just divide it by the n-1. If you have to calculate from the total population, then you have to calculate divided by the total number of terms. I hope you understand the concept of the standard deviation. Now let's talk about the variance. Now, variance is, in simple terms, it is the square of the average distance between the each quantity and the mean. You can say that it is the square of the standard deviation. So, standard deviation and variance, these two are a kind of interlinked. And in most of the institutions and in the universities, they just say like standard deviation and variance. They just teach the standard deviation and variance together because these two are the interlinks. They have like the same formula for that. Standard deviation and the variance have the same formula. The difference is that if you take the square root of the standard deviation formula, like I have this standard deviation formula right here. If I just take the square on both sides, then this square will definitely cancel the square root and it will become a variance. In other words, you can also do this. Like you know the variance formula here, and what did you do? You just go and you just put the square root over here, right? Just put the square root over here and it will become your standard deviation. That's it. So variance and standard deviations are interlinked. They both have the same concept behind this. Understand? The variance also, if you have any kind of queries, you can definitely ask me.